terms, and more terms. So what you're seeing right here is a lesson just talking about all kinds of different terms. I just wanted to make sure that I was recording. So what we're going to do is we're going to talk a lot about identities, but also different things that might come up in just terminology. So what we have here are identities, and identities are like something, the root word identity is like identical. So reciprocal identities means that you flip it over. So sine theta, this is a theta letter, and we oftentimes use theta, is 1 over cosecant. And you might think of sine and cosecant as being cousins, I guess. Cosine and secant being cousins, and tangent and cotangent being cousins. So it's just 1 over cotangent, but then the opposite is true also right over here. Cosecant is 1 over sine theta, and secant is 1 over cosine theta, and so on and so forth. So if we wanted to figure out the value of cosine theta if secant theta was 5/3, we know that cosine is 1 over secant. And so we could say 1 over 5/3. And you're going to kind of see that this just flips over and like that, and becomes 3/5. So if we had, I don't know, cosecant theta being 1/3, then sine theta would be 3. It just flips it over. And so kind of important idea here, because it allows you to come up with the other trig function fairly fast. So those are some terms that we would have. There's just another one. One important idea is this word, this acronym that says all students take calculus. And this is a quadrant, you know, a coordinate graph. And everything in the first quadrant, all trig functions are positive in the first quadrant. So if we make a triangle into that quadrant, all the trig functions are positive. If it's in the second quadrant, sine and cosecant are positive. And if it's in the third, t, tangent, and its cousin cotangent are positive. And c, calculus, cosine, and secant are positive. So you know that if you're in the fourth quadrant, everything's going to be negative except for cosine and secant. And if you're in the second quadrant, that's the students. So all students, and the S stands for sine, take, T stands for tangent, calculus, C is cosine. So most people that are taking trig or pre-calc B are on their way to calculus eventually. Not everyone, but most are. So identify, one of the things that they like to do to us is they like to identify the quadrant or quadrants that satisfy these kind of conditions. So let's just say we have sine is greater than 0. I want to help you read this. This just means sine is positive because it's greater than 0. Anything greater than 0 is positive. So when sine is positive and cosine is negative, which quadrant are we talking about? So where is sine positive? So let's go ahead and just circle that. And when is, well, it is here too, sine, at both of those places, it's positive. Now, when is cosine negative? Well, cosine is negative here and The cosine is negative here. So which one did we circle twice? Well, the one we circled twice is this one. I also have it on the PowerPoint, so let me try that. Oh, no, it doesn't. So I thought I had it. It was, never mind. So whenever you circle one twice, that means that it is true. So that one is satisfies both. So let me clear this off and go back to this. So tangent is negative and cotangent is negative. So when are these trig functions negative? Well, tangent is positive in the first and third quadrants. So it's negative here and negative here. So the answer is both the second quadrant and the fourth quadrant. And one thing I failed to say is that these we usually use with Roman numerals when we're talking about quadrants, but first, second, third, and fourth. Here's another one. Sine is positive because it's greater than 0. Tangent is negative. So when is sine positive? Here and here. And when is tangent negative? Well, tangent is positive in the third quadrant, so it'd be negative here and here. So where is it circled twice? The second quadrant. So our answer is the second quadrant. Now, one of the things about trig functions is the range. Remember, range is up and down, up and down. So how tall does the graph get? And as we start to talk about graphing of these, this is going to make a whole lot more sense, but they introduce it earlier on before they talk about graphing of it sometimes. So any sine or cosine must be between -1 and 1. So the values have to be between -1 and 1. That's its range. And I'm going to give you the graph of it just because I think it's important to see this. So if you took this and put this in Desmos or something like that, you would know that the range is from -1 to 1. And the same is true about, this is the cosine function, and cosine would be from -1 to 1. A little off there because of my lines drawn, but it'd be from here to here. So it doesn't get any taller or any taller than 1, any less than 1 on the y-axis. That's with cosine and sine. So you got to remember that the values are always going to be between 1 and -1. So when you use your calculator on Alex or your graphing calculator, it's always going to be between -1 and 1 when you do tangent. Tangent and cotangent can be any number. So just keep that in mind. So tangent and cotangent, they can be anything. And then the other one, secant and cosecant, are never between -1 and 1. So they're the opposite of this. So what they're the opposite of the first example. So in this one, everything's between here. Let me draw it. Between here and here. Now, with cosecant, which is a cousin of sine, and secant, which is the cousin of cosine, they do something like this, make little parabolas. So what happens is the graph doesn't go between 1 and -1. So here's the axis, and it never goes through 1 and -1. So there's this gap, big hole here between -1 and 1. So it has to be either greater than 1 or less than -1 for your answers with cosecant and secant. So sometimes they like to ask those kinds of questions. So let's just answer a few. It says sine of theta is square root of 8. Is this possible? Well, the square root of 8 is 2.89. So sine has to be between 1 and 1 and -1. So this is false. Tangent can be 110.47. This is true. Sine can be 2. Well, that has to be false because it has to be between 1 and -1. Cosine be 0.98? Yes, this is true. you can have a value of 0.98. So possible and possible. I've used false and true. So some other identities, the really, the reciprocal identities that I gave you at the beginning were important, but Pythagorean identities are very important. And you guys know the Pythagorean theorem as being a squared plus b squared is equal to c squared. That figures out a right triangle. So it has those things. But when you're talking about the Pythagorean identities, it's sine squared theta plus cosine squared theta is equal to 1. And I got to point out that the theta can be x, it could be y, it could be any variable. But a lot of times in trig, we use theta. But I do notice that in ALEKS, they use x a lot. So that's fine. It's just easier to write. Just be careful with the x's. So sine squared x plus cosine x squared x is equal to 1. And then tan squared x, or tan squared theta, plus 1 is secant squared theta. And 1 plus cotangent squared theta is equal to cosecant squared theta. So really important identities. And you must memorize them because they're just like second nature. We have to know what they are. Now, I want to point one thing out because I didn't know this for a long time and it made me crazy. I'll use x instead of theta. Okay, so sine squared theta means, really important, sine x all squared. It means there's two of them. So it means sine x times sine x. Sometimes this very elementary idea doesn't sink in because the 2 is after the sine and the 2 is after the tangent, the 2 is after the secant. So you don't understand that it's meaning the whole thing's being squared. So just keep in mind, if I say tan squared x, this means tan x all squared. Does that make a help? I hope that helps. Now, one thing you can do, I'm going to have to reshare my screen. One thing that can happen, or one thing that we should point out is that how to remember these. How I remember this one are tan 1s are sexy. So tan 1s are sexy. And the other one is cotton 1s are cozy. So this is cozy. This is cotton 1s are cozy. And those, because it's the commutative property, you can switch those around. Cotangent squared x plus 1. The other identity that's really important is the quotient identity. And they have to do with tangent and cotangent. And tangent is always sine over cosine. And cotangent is cosine over sine. So if you have anything that ever comes up cosine over cosine, sine theta over cosine theta, that means tangent theta. Okay, one of the big ideas is reference angles. And reference angles are, they have two of them. They have reference angles and what's the other one? I can't remember it off the top of my head. Reference angles always are found to the x-axis. So what I have here is a angle, this purple angle that you see there. And it says it's the positive acute angle made with the terminal side of the angle theta and the x-axis. that's kind of confusing, at least to me. But let's just say this was 130 degrees. So that looks about 130. 130 degrees, 90 degrees would be up to the y-axis. But 130 degrees, the reference angle is always to the x-axis. So it's this one right here. And that is, we usually put it with a prime sign, but I'm not going to say you have to. They just want to know what the reference angle is. Now, you know that 180 degrees is from here to here. So this would have to be 50 degrees. So whenever you're trying to find reference angles, you're always referencing them to the x-axis. So keep that in mind. Now, some of the other terminology that here, it says terminal side. So we're taking this blue line that we have here, we're rotating it over until it gets in this red right here, this red line. So you think about grabbing onto this blue line right here and whisking it around. This is going to be what we call the terminal side. So again, if this was 120 degrees, this would be 60 degrees. So your reference angle is always 60 degrees, and we usually make a little triangle out of it. Okay, so reference angles. Let me do another one. So here's a angle, and the reference angle would be right here back to the x-axis. So this one the theta measure might be, it's more than 180 because 180 would just be a straight line. Let's say 190. So this would be, let me go with a different color. This would be 10 degrees. So you're always trying to figure it out towards the x-axis. So here's an actual example. We go clear around 292 degrees. Remember, this is 90 degrees, 180 degrees, 270 degrees, 360 degrees. So if you go around a whole circle, so 292 is more than 270. So it's got to be in the fourth quadrant. And to figure that out, we'll just take 360 minus that 292. But sometimes you have to subtract it from 180. Sometimes you have to subtract it from 360. Sometimes you have to go around it multiple times and then figure out what the angle is. So this one looks like it's 1258. So if we take 1258 and start subtracting 360 off, we're going to get an answer, and then we have to subtract that off 360. And actually we had to subtract it 3 times to get to 178. So a straight angle is 180 degrees. So this is going to be only 2 degrees right here from here to here. So the reference angle is only 2 degrees. So they'll give you a big number. Now, if they give you negative, remember you have to go the opposite direction. So I'm going to clear this off. Okay, so really important part here, okay? Very important. And I know that the answers are there, but I want to explain where it comes from. They are talking at this point about 120 degrees. So let me change the color here. So what we're interested in is, what is sine of 120 degrees? So we'll just start off with that one, then we'll go to cosine of 120 degrees. Now, if we're doing it by hand, there's no way for us to know exactly what that is. So what we have to do is figure out what this reference angle is, which is 60 degrees. And then we make a little triangle. Now, remember from yesterday, or the previous assignment, the famous triangles, 30, 60, 90 triangle. So this is a 90, this is 30. And opposite of 30 is always 1. Opposite of 60 is square root of 3. and the long side is always 2. And so the reason why this is -1 is because we're in the second quadrant. So this value right here is -1 rather than +1. Opposite of 30. So opposite of 30, what I'm meaning right there is that it's -1. So sine of this 60-degree angle, opposite over hypotenuse, is square root of 3 over 2. Sine of 120, oh, I'm sorry, cosine of 120. Cosine of 120 is adjacent, which is -1 over 2. And tangent of 120 is opposite over adjacent. So square root of 3 over -1, which we would call as the square root of -3. But if we wanted to know cosecant of 120 degrees, we'd have 2 over square root of 3. That's just this flipped over, and multiply top and bottom by square root of 3. And we get 2 square roots of 3 over 3. And secant, as being 120, is -2. And cotangent of 120 is -1 over square root of 3. And so we rationalize it, must rationalize. So we have these values of 120. Now, you notice on the right side over here, I have sine of 60, sine of cosine of 60, tangent of 60. That's because that's the reference angles that we're using, so we know where everything is. So all they gave us, they didn't give us all the square root of 3, 2, and 1. All they told us was that it was 120 degrees. So we had to figure out 60. And if this was in the first quadrant, we wouldn't have to worry about the minus because it'd all be positive. Now, remember, all students. So everything needs to be negative except for sine and its cousin cosecant. So this one and this one are positive, notice, because it's in the second quadrant. The rest of them are negative. So you can double check yourself with your negatives as you go. Okay, so this one is 210. Again, our reference angles here, I have all the, let's just cover this up because that's really not what I want to know. But sine of 210, I need to go cosine of 210 and tangent of 210. Let's just do the first 3. And one thing they do in ALEKS is sometimes they go sine of 210, cosine of 210, and then cosecant of 210. So they skip them, and they instead of making you do 6 of them, they just make you do 3 of them. But you have to figure out almost all of them to do it. Okay, so 210, the reference angle, if that's 210, if you subtract 180 from that, that's 30 degrees. So this is 30 degrees. And I'll make a little triangle here. Let's see if I have that triangle. Yeah. Oh. Let me erase that. Erase this. Okay. So this is 30 degrees. And they're going to put a line here. So that's a right angle. And this is 60 degrees, 90 degrees. And opposite of 30 is 1. But that's not a 1. That's a -1 because we're in the third quadrant. And it's minus square root of 3 because that's opposite of 60. This is 2. So those are the lengths of the sides. So sine is, opposite over hypotenuse, so -1 over 2. And cosine of 210 is negative square root of 3 over 2. And tangent is -1 over negative square root of 3, because it's opposite over adjacent, and SOHCAHTOA. And what we have to do is, there are two negatives make a positive, so, but we can't leave this answer because it won't like that answer. We have to rationalize our denominator. So square root of 3 over 3. So that's our answer. Good? So this one's negative 240. Yeah, that's good. We want to know the exact value of negative 240. So you know that triangle goes this way because it's minus degrees. So it's going to be into the second quadrant. And if we take 360, well, we don't want to go 360. Let's go 240 plus 180. I don't know. Let's subtract those, we get negative 60. The difference is 60. So this triangle right here is a 60-degree angle. And this is 30. And this is 90. So remember that opposite of 30 is 1. But this is going to be -1, because I always have to keep on saying that to myself. Opposite of 30 is 1. Opposite of 60 is the square root of 3 and 2. And you might be sitting there going like, well, why is it always 1, 2, and square root of 3? Remember those, the triangles, the famous triangles, the 45, 45, 90 triangle and the 30, 60, 90 triangle. That's why it is. And if you do the Pythagorean theorem on it, it works. So this, the square root of 3 is positive. So, and we're referencing the 60-degree angle. So when we go and try to figure out what cosine of negative 240 is, what we need to do is go opposite, which is, what is that opposite? Oh, cosine, I mean, it's adjacent, so -1 over hypotenuse 2. Remember, hypotenuse is always positive. So we get this answer of -1/2. Now, a lot of you might be saying, well, can I use a calculator? Because that's going to be -1 or 0.5 or -0.5. It would give you -0.5. But when the other ones come about, like sine of -240, that's going to be square root of 3 over 2. So you have to be a little bit careful because yeah, you just have to be careful because it doesn't always work that way. But again, think of all students take calculus. Sine is positive here, cosine is negative, so double check those. A lot of people want to say, oh, it's a negative angle, so the answer is negative. That's not true. This is negative, this is positive. So this is negative, this is positive. So it doesn't mean that the answers are going to be negative. It just depends on where you're at on the axes. Oh, yeah. Okay, that's pretty much it. But the other thing I can say is that, and that's what this is going over, there's a rule, an identity in trig, that if you have a cosine of a negative number, it's the same as saying negative cosine of theta. So if you took that and said 60, then you find the cosine of 60 degrees, which was over here, it would be positive and you're good. I suggest when you're doing these problems that you draw out your axis. Otherwise, it's just, you're guessing. And that's the frustrating part of some of these problems, is because you're just like, I don't know exactly what to do. So draw yourself your axis, figure out where negative 240 is, find the reference angle, make your little triangle. You know that this is 60, this is 30, this is opposite of 30 is 1, but it's -1 because it's in the second quadrant. Square root of 3 and 2. And then you should be kind of good. So let me do a new slide here and present it. Okay. So I just wanted a clear slide. So if I wanted to know, because I didn't do any 45s. So let's just say I want to know sine of 225. So let's just draw our triangle, or draw our axis, I should say. And we'll go over here 180. To subtract 180 from this and you get 45. So it's going to go another 45 degrees, which is halfway in between here. And so this is 45 degrees. I'm going to erase this. Okay. So this angle, the reference angle is 45. And it doesn't matter how big your triangle is. It doesn't really matter. Now, remember with a 45, 45, 90 triangle, you have 1, 1, and square root of 2. And those are the values that we have. So the hypotenuse is square root of 2. And because this is in the third quadrant, both of these are negative. And you might think of this as -1, -1 right here. So you have -1, -1, and square root of 2. Hypotenuse is always positive. Remember that. Okay, so this line right here is always positive. So if we wanted to figure out the sine of 225, sine is opposite, which is -1, over hypotenuse, which is square root of 2, multiplied top and bottom by square root of 2, and you get negative square root of 2 over 2. And if we had, I don't know, let's just say cotangent of 225, because they randomly do them. Remember that tangent is opposite over adjacent. So cotangent is adjacent over opposite. So if we're looking at this angle, we're going to talk about this side over this side, to be -1 over -1, which is 1. Again, all students take calculus. Tangent and cotangent, tangent and its cousin cotangent, are positive, and that's why this is a +1 and this one is a negative square root of 2. And one other thing you're going to notice about this is cosine of 225 is also -1 over square root of 2, which is going to give you negative square root of 2 over 2. So this, I want to end this with one idea. And you might be saying, okay, what about sine of 102 degrees? It's not part of this. Well, it is part of it. We have to use calculators for that. But for the basic ideas of anything that's a multiple of 30 or 45, or 30 or 45, all the way around the circle from 0 to 360, all the way from 0 to 360, you're always going to have exact answers. So if you're trying to figure out sine of 102, I'm sorry, you would just punch in the calculator and get the decimal answer. But if you were trying to figure out the sine of any multiple of 30 or any multiple of 45, remember 30 goes up 30, 60, 90, 120, 150, 180, so on and so forth. And 45 goes up 45, 90, 135, 180, 225, 270, 270, 295 and then 360. I don't know. Wait a minute. 45. I don't know what it was. I think it's oh shoot. 315, maybe. I don't know. 315. I'm not sure. But anyway, it has to be in these multiples. And we are really interested in them, and because they come up all the time, and they tie to calculus because they tend to do a lot of their calculus ideas with sine of 45 or sine of 60, because if you understand that, then you know whether your answer of sine of 102 is kind of correct, because you have an idea of what to estimate it on. So it's a building block. So just like when you learned algebra for the first time, trig is one of those things that you don't have a lot of background for. So you're just kind of putting it all together. And that's why I'm doing these videos. So hopefully this helped a little bit. And I'll get this posted. So have a nice day.